Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be going over how to calculate the amount of mercury that's in a lake. So let's get into this. So in this problem we're given that the amount of mercury in a polluted lake is 0.4 micrograms of mercury per milliliter. We're given the surface area of the lake. The lake has a surface area of 100 miles squared and an average depth of 20 feet. And then, so they want to know how many kilograms of mercury are in this lake. So, how do you attack this problem? A lot of information. So, the first thing we want to talk about is the volume of the lake. So, notice that they're giving us the average depth, right? They're giving us the surface area. So, that's the surface area of the lake. And here we can, since it's a lake, we can assume that it's a circle, right? Lakes have a kind of a circular, well, some lakes anyway. So here we're talking about a lake that has a circular circumference or surface area. And we're told that the average depth is 20 feet. Well, why average? Well, you know, the bottom of the lake is not straight. It could be high, it could be low. If you do an average, well, that kind of flattens everything out, right? So if you take all of the highs and lows and you average them out, you basically are flattening the bottom of the lake to 20 feet all around. Well, what does that give you? It gives you a cylindrical volume. So you have a lake that has a cylindrical shape, cylindrical volume. So you can use the volume of a cylinder to find the volume of the water. So if you take the volume formula for a cylinder, that's going to be the area of the cylinder or the lake. That's your surface area multiplied by the depth or length of the cylinder. So here we could put a D for depth, right? So the area times the depth. The area, we're going to assume that's a circular area, so it's pi r squared. So it would be pi r squared multiplied by the depth of the lake. And so that'll give us the volume of the lake. So in this case, all we need to do is find the radius, multiply everything together, and we'll get the volume. Now, we want the mass of the mercury in the lake. So notice they're giving us the density here, or the concentration, if you will, of mercury in the lake, right? So we're told it's a 0.4 micrograms per milliliter. We've got a relationship between milliliters volume and mass in micrograms. So if we could get the volume of the lake in milliliters, we can then use this to convert milliliters to micrograms, and then take micrograms, convert that to kilograms. So that's our plan of attack. So let's get started. So the first thing you want to do is convert to centimeters. Why do we want to convert all of our area and depth to centimeters? Because when you get the volume, you're going to get centimeters cubed. And we know that 1 centimeter cubed is equal to 1 milliliter. So that's where we're going to get the milliliters from to use this conversion factor. So let's go ahead and get started. So first thing we want to do is find the radius of our lake, or we got the area. So we don't even need this actually. This is unnecessary. So here we have area times depth. They're giving us the area, so we don't need pi r squared. Sorry about that. So now all we need to do is convert that to centimeters. So we'll use our conversion factors. So 100 miles squared over 1. First thing we want to do is convert to feet. So 1 mile is 5,280 feet. So we're going to use that as a conversion factor. So since I have miles here, I'm going to put 1 mile on the bottom. And 1 mile is equal to 5,280 feet. So I'm going to put 5,280 feet. But then you're like, Mr. Caldwell, wait a minute. This is not miles squared. But you only have miles there. Hold on, I'm not done. I'll explain now. So since this is miles squared, we want miles squared here. The easiest way to do that is to square the whole thing. So we're going to square this. So now we have miles squared over feet squared. Everything is squared. So when we do our calculation later, we're going to have to square these numbers. Okay, so we have that. Now we have feet squared on top. So miles squared cancels out. And now the next conversion factor, I want to convert feet to inches. So 1 foot on the bottom, 12 inches on top. So again, we're going to square this because we have square feet. So now the feet is going to cancel out. Now we have square inches. And last, we want to convert inches to centimeters. So we're going to do this. So we want inches. We have inches on top. We want inches on the bottom. So 1 inch on the bottom. And so 2.54 centimeters on top. And again, we're going to square this. So inches squared cancels out. And now we have centimeters squared. So all we have to do is calculate this by multiplying by everything on the top here, dividing by everything on the bottom. All the bottoms are ones. So that's all we need to do. So when we calculate this, we get 2.589, 2.58 times 10 to the 12 centimeters squared. So now we have our area in centimeters squared, 2.58. Now, for sig figs, we want to pay attention to sig figs. Remember, the answer you get, the rule is that if you're multiplying and dividing, your answer should have the same number of sig figs as the least number of sig figs in the measurements you're multiplying and dividing. So here we have 1 sig fig. The zeros are not significant because there's no decimal point. Here, this is exact, so we can ignore this. This is exact, so we can ignore this. This is exact, so we can ignore this. So we only have 1 sig fig here. So this is the only sig fig we need to worry about. We got to use this number in future calculations, so we'll keep an extra digit or two. Always keep at least one extra digit when you're using the number later for further calculations. Okay, the next thing is to convert 20 feet into centimeters as well. So that's our distance. So we're going to take 20 feet over 1. And again, we'll follow the same pattern here. So 1 foot on the bottom, 12 inches on top. Feet cancel out. And then we're going to convert inches to centimeters. 1 inch on the bottom, 2.54 centimeters on top. Inches cancels out. And I have centimeters. So now all I have to do is multiply across the top, divide by the bottom, and I get my answer. And when I do that, I get 609.6. So 609.6 centimeters. Again, significant figures is important here. So when you're multiplying and dividing, your answer should have the same number of sig figs as the least number of sig figs in your measurements. This is exact. This is exact, so we can ignore those. This is 1 sig fig, so our final answer should only have 1 sig fig. We're going to underline that to notify that we only get 1 sig fig. And so now we're going to use this further, so we'll keep an extra digits. And then now all we need to do is plug these numbers, area and distance, into the equation for volume. When we do that, volume is equal to 2.58 times 10 to the 12 centimeters squared multiplied by 609.6 centimeters. And that's going to be equal to 1.572 1.572 times 10 to the 15 centimeters cubed, which is equal to milliliters. So this is the same as 1.572 times 10 to the 15 milliliters. Okay, now for sig figs. Now remember, here we have one sig fig, we have one sig fig. So we're multiplying it again. So the number of sig figs here should be the same as the number here. So we're only allowed to have one sig fig here. But we're going to use this in further calculation. So I'm going to keep the rest. Now I have the volume of the lake. Now all I need to do is use this as a conversion factor to convert milliliters to micrograms. So I'm going to go to mass. I'm going to convert the volume to mass. So I'm going to take my 1.572 times 10 to the 15. Let me double check to make sure I got that right. Yes, 15 centimeters. Oops, that's milliliters. Milliliters of water, and I'm going to then multiply by this conversion factor. So I have 1 milliliter on the bottom. That's going to cancel out, and I'm going to put 0.4 micrograms of mercury on the top. So milliliters cancels out. Now all I do is I multiply these two numbers together, and when I do that, I get 6.291 times 10 to the 14 micrograms of mercury. I have one sig fig here, right? So one sig fig there. This is one sig fig. So again, when I'm multiplying and dividing, this should be one sig fig as well. So that one there. Again, I'm going to keep the extra digits because I have to now convert this to kilograms. That's my last thing. Now that I have micrograms, I'm going to convert that to kilograms of mercury. So we're going to take the 6.291 times 10 to the 14 micrograms of mercury, and we're going to put that over 1. And so now all I need to do is convert micrograms to kilograms. So the first thing I'm going to do is I'm going to use the base unit as a middle place. So I'm going to convert this to micrograms. I'm going to convert it to grams. Why? Because I know the relationship between micrograms and grams. Micro is 1/1,000,000th of a gram, or 10 to the negative 6. So 1 microgram is equal to 10 to the negative 6 grams. So I can use that. So I'm going to put 1 microgram on the bottom and 10 to the negative 6 grams on top. Now, the other way you could do this is you can think that 1 gram is equal to 1,000,000 micrograms. That would be the same thing. So either one works. So now micrograms of mercury cancel out. And here I have grams of mercury. Now that I have grams, now I can use the grams to kilograms relationship. Kilo means 1,000. So if I have 1 kilogram, that means I have 1,000 grams. So now I can use that to convert. So if I know 1 kilogram is 1,000 grams, I have grams on the top. I want to put grams on the bottom. So that's going to be 1,000 grams. So 1,000 grams on the bottom, 1,000 grams of mercury, and 1 kilogram of mercury on top. So grams cancels out. I have my kilograms of mercury. I am done. Now all I need to do is calculate, multiply across top, divide by the bottom. And when I do that, I get 6.291 times 10 to the fifth power. And that's the number of kilograms. But remember, we have one sig fig here. This is exact. This is exact. So my answer should have only one sig fig. So the final answer is going to be, oops. Sorry about that. Final answer is going to be 6 times 10 to the fifth kilograms of mercury. And that's how you do that problem. I hope this was helpful. If you enjoyed this video, if you learned a lot from this video, then please, by all means, like the video, share the video, hit that like button. Also, subscribe to my channel, hit that notification bell. When you do, make sure you click all so you can be notified by all the videos I put out. Finally, put a comment down below. If you have a question, put it down below. Let me know what you think. If you have a problem you want me to help you with, or a question you need help with, or a topic you would like me to cover, put that down below. I would love to do that for you. Thanks for joining me and have a great day.